हेलो स्टूडेंट्स, एक क्वेश्चन देखते हैं. देखिए राइट, इस क्वेश्चन में क्या है, स्टेडी करंट आई फ्लोज अलोंग ए इन्फिनिटली लॉन्ग हॉलो सिलेंडर conductor. Okay, hollow cylindrical conductor of radius r. So let us see what is given in the question. And this cylinder is placed coaxially inside a infinite long, right, infinite solenoid of radius 2r. So let us make the solenoid first. So this is like this solenoid. Okay, and that is also infinite. Okay, and inside it a infinitely long hollow cylinder is placed. So inside this one, okay, inside this one a hollow cylinder is placed. Okay, now it is saying like this, and the current is flowing in the hollow cylinder long, the current I is flowing. So suppose this is current I is flowing here. Okay, and solenoid, the radius of solenoid is given 2r, and the radius of the hollow cylinder is given capital R. Okay, the solenoid has n turns per unit length. The carried is once again solenoid also carries current I. So this is also carrying current I. Okay, and consider a point P at a distance. Right, consider a point P at a distance from the common axis. उसके बाद आपको स्टेटमेंट्स बतानी है. तो दिस इज द फिगर. नाउ लेट अस गो बैक टू द ऑप्शंस नाउ. सो इट इज सेइंग इन द रीजन फ्रॉम 0 to r, right, r is between 0 to capital R. So the magnetic field will be non-zero. See, right, here the two things are there. One is hollow pipe, and right, that is cylindrical pipe. Right, cylindrical, right, one thing is cylinder here and another thing is solenoid. So let us see the option A first. It is saying between 0 to capital R. I mean, from this is the axis. If I take, let us see. Okay, right, let us take, this is the axis here. So this line I am taking axis. So it is saying from 0 to R, I mean in this region. So in this region the field due to cylinder will be 0, but the field due to magnetic, right, but the field due to solenoid will be there. So in this region for the option A there will be some field, but here it is saying, okay, in the region from 0 to R the magnetic field is non-zero. So option A is correct, because in this region you will get the magnetic field due to the solenoid. Okay, and that is mu naught Ni, but due to the cylinder you won't get any field. Okay, so the overall there will be some field here. So option A is correct. Let us see in the B option. In the region R, right, R is greater than a small, right, right, capital R and 2R. So it is talking about this region, right. So it is talking about this region, right, this one. So let us see in this region you will get the magnetic field due to both. Due to cylinder also you will get the magnetic field, and due to solenoid also you will get the magnetic field, right. So there will be some magnetic field here. So in the region this, the magnetic field is along the common axis. Okay, this won't be there because right, because due to the, right, because in this region due to the solenoid the field will be along the axis, that is correct, but due to the cylinder the field will be perpendicular to the axis. Right, it will go like this. So it will go perpendicular to the axis. So overall the sum of these two vectors will not be along the axis. So this option is wrong. Okay, once again I make you understand, right. See, in the option B the magnetic field is saying along the common axis. Okay, now see, for the, from the solenoid the field will be along the axis, that is correct, but due to the cylinder field will be not along the axis, it will be perpendicular to the axis. So when both the vector will get added, the resultant will not be along the axis. So option B is wrong. Now let us talk about in the region a small r, capital R this. So once again C option is also talking about this region. Okay, let us see. The magnetic field is tangential to the circle of radius r centered on the axis. This will also be wrong, because once again, right, due to this one, right, due to the pipe magnetic field will be right along the tangential to the circle, but due to the solenoid the field will be along the axis, and when both the when both the vectors will get added the field will not be tangential to the circle. So option C is also wrong here. Let us see the option D. In the region where r is smaller than, right, when the r is greater than 2r, so it is talking about outside the solenoid, the magnetic field is non-zero, and that is correct because when you go outside the solenoid, I mean in this region, so because of the solenoid you won't get any field, but because of the pipe or because of the cylinder you will get some field. So in this region you will get some field here, so it is talking about it is non-zero, so option D is correct. So the correct option is A and D. Okay students, I hope you understood this question.